I just want to go over this table to make sure that you've got the correct equations in here. So velocity as a function of time, that is Vf equals v naught, the initial velocity, plus acceleration times time. Position as a function of time is going to be a little bit longer equation. This is the long equation, so we have our final position equals our initial position plus our initial velocity times time plus 1/2 at squared. Told you it was long. All of that goes in there. I can't write that small. You probably can. So there you go. The no time equation, that is our final velocity squared. That's the equation with no time in it. Initial velocity squared plus 2a delta x. And then finally the last, acceleration without acceleration. Acceleration without acceleration. Yes, that's what I mean. That is our displacement equals our initial velocity plus our final velocity divided by 2 times t, or delta t. Define all of the symbols with the units, please. So like Vf is final velocity. I'd write out final velocity. And I need to know that it's measured in meters per second. Initial velocity. Know that it's initial velocity. Also measured in meters per second. Xf, final position, measured in meters, and so on. Okay. Alright, on to the guess method for different situations. A car can go from 0 to 30 meters per second in 2 seconds. Determine the car's average acceleration. Alright, so what information are we given? We are given from 0, so we know the initial velocity is 0. I'm going to not write the units to save space, and hope that helps. We know the final velocity. It's going to 30 meters per second. I can't write any thinner for some reason. This is as thin as it goes. Annoying. And then we have time, 2 seconds. Determine the car's average acceleration. So what are we looking for? The equation, we're looking for acceleration. We have final velocity, we have initial velocity, and we have time. Then we're just going to use v equals a times t. This is the shortcut, abbreviated version, right? Because we have our initial velocity is 0, so our final velocity equals acceleration times time. And then we can just solve for time, and we get acceleration equals velocity, final velocity over the time taken. So we get our acceleration equal to 15 meters per second squared. Car can go from 0 to 230 meters per second in 3 meters per second. So they're in 3 seconds, excuse me. Here's our initial velocity. I'm just going to write it like this. Please put it into the guess method just for not safety. Space, Vf. And then time is 3 seconds. How far? What will answer that? The unknown is going to be our displacement. Does the car go while it accelerates? So we have displacement, we have initial velocity, final velocity, time, while it accelerates. Looks like we have acceleration, but we don't have acceleration, right? So here's that. Delta x equals v naught plus vf divided by 2. times time. Plug that in there. Hopefully we get x equals 45 meters. An aircraft starts from rest and accelerates on a straight runway at a rate of 8 meters per second squared, acceleration, for 400 meters. A distance, or displacement, distance. An aircraft starts from rest, so this is initial velocity. How much time does it take? We are looking for t. We have a, we have initial velocity, and we have position. So which of those four equations can we use? Because we have this, and we're looking for time, we have acceleration, we're going to use x equals v naught t plus 1/2 at squared, and of course we can take the shortcut. This is not true every time, but our initial velocity is 0, so all of that junk goes away. And we can move on 1/2 a, so half of a is 4 times t squared. Don't forget that squared. Divide each side, so we have 400 divided by 4, and that'll give us t squared. T should be the square root of 100, or just t equals 10 seconds. And then a nice circle of the answer to show that is my answer. Remember, when you're solving free response problems, the point is not the answer. In fact, the majority of the points are not connected to the answer. Very rarely will you receive anything more than 1 point for a correct numerical answer. Instead, it's all of the steps listed above. So this guess method will show you the steps, especially this E, for choosing the right equation. I can't tell you how many times I have seen a point awarded for using the correct equation. So if you write out what's given to you, the unknown information, and there's an equation that relates these two things, easy point. A test car accelerates from rest, initial velocity is 0, at 4 meters per second squared. There's the acceleration over the course of 200 meters. There's x. How fast does the car go at the end of this acceleration? So we're looking for our final velocity. We're given position, we're given acceleration, we're given an initial velocity. We're looking for final velocity, right? So there's no time, so we're going to use the equation without time. Vf squared equals v naught, which is 0, plus 2a delta x. 2 times a times delta x. 200. 2 times 4 is 8. So that's 1600. Square root of 1600 will give us 40 meters per second. Vf equals 40 meters per second. 5, we'll have to wait. I'm out of time.